Fluid resistance. If you've ever stuck your hand outside of a moving car window and felt the push of that air, you've experienced fluid resistance. The direction is always opposite that of motion, and the magnitude increases with the speed of the moving body. And unlike kinetic friction, which is independent of speed, this has a value of a speed in the equation. So for small objects at low speed, the magnitude of the fluid resistance is equal to kV, where K is a proportionality constant that's a function of the size and the shape of the moving body, and V is the velocity of the moving body. This is good for dust particles moving in air, or say a ball bearing moving through oil. For larger, faster objects in air, such as a skydiver jumping from a plane, the drag or the fluid resistance goes up as the square of the velocity. This is called air drag. And the equation is F equals D times V squared, where F is the magnitude of the drag force and D is a proportionality constant. It's a function of the size and shape of the body and the air density. V is the square of the velocity of the moving object. Terminal velocity. Because of fluid resistance, an object falling in a fluid does not have a constant acceleration. When the object first starts to fall, its velocity is 0 and the initial acceleration is gravity. As the speed increases, the resisting force also increases until it's equal in magnitude to the weight of the object. At this time, the object no longer accelerates and has achieved what is called terminal velocity. Those equations are as follows. For small objects, the terminal velocity is going to be equal to the weight of the object divided by K, that constant of proportionality. And this is because, if you recall, the drag force, or the force of resistance, is going to be equal to kV. We are setting that equal to mg. Therefore, V is going to be equal to mg divided by K. For larger objects, where the drag force goes up as the square of the velocity, your terminal velocity is going to be equal to the square root of the weight of the object divided by D.